So you just created your first project. Now let's take the Segway out and use it in different environments. The first environment, which is probably the first environment you should be testing in, is Vicon. Vicon gets rid of all the problems that you have to deal with pose, and you get like truth pose. So to turn the Vicon system on, you come to the first Vicon system right here, and it's 3 switches. The first switch is over here, turn it on. Second switch is over here, turn it on. Third switch is over here, turn it on. As you can see, the camera should begin to light up, and they will all turn green. And when they're green, they're ready to go. Red means they're actually on. As you can see here, some of them already started. Yeah, you can see over there, those blue ones are on.
Is Vicon, is it off on the program?
No, yeah, it's off in the program.
That means so the lights won't come on.
Hey, come here, come here. So, once you turn the Vicon system on, you have to actually turn the system on from over here. Open Nexus. Always say yes. So default Nexus system subjects, the default is not this one. If you want to get the right test, make sure you press open, and it'll bring you to the screen. Choose Eric's tests. Eric's tests, which are right here, calibrated Segway. And once you double click on it, it'll load them. As you can see, the Segway here is the blue Segway, which is sky blue, which was the one we're using. You can uncheck all of these boxes just to save the computer from trying to figure out the amount. If it's checked, that means it's trying to find it. If it's not checked, then it's not trying to find it. Okay, this is good enough. Let's go. So now, we're going to run our project. First thing we need is our controller. So we're using Sky Blue Segway, so we're going to find the Sky Blue controller. It's right here. Let's come over here. Get your computer and open your project, which we saw here. Once we run the project, our robot should start. Open the thing. Maneuver it so you can see everything clear. There's different views as I explained in the last video. So we'll start. We're going to use Vicon Pose Fighter and start the robot. As you can see, the robot is right there, and it has no control from the controller. The robot here has the LiDAR scans. If I go and walk in front of the LiDAR scans, it will pick me up on the screen. Now, you always want to make sure the robot runs before you start doing anything. Now, once your code runs, you can switch the batteries off the power and onto the actual Segway. So now that your program runs, you want to switch to a portable battery so you can move the robot. Never drive the robot when it's connected to a power cord. It's really bad. To turn the battery on, we're going to turn the battery on. Make sure DC is facing upward. And we're going to slide it into battery connectors. It might be a little bit tangled from the wires, but our new design solves that problem. Plug the battery inside the connector by rotating, twisting it on, turn the battery on, and plug it in. Now you notice that both lights are off now, which means that it's drawing power from both. So then you can turn off the power supply and remove that battery. Now the robot's ready to move. Notice before you do anything is that the Segway light is on. You can also know if the Segway is on if it's easy to push. Make sure you toggle the switch before you start and wait for the beep. Once you hear that beep, you'll feel the robot much more difficult to move, and that means the Segway motors are on. So now we have our controller, which allows us to drive the robot around, as you can see here. And now we're going to run our program, and we're going to use it. We're going to use the Vicon Pose Fighter. We're going to start the robot. Oh, wrong way, wrong way. As you can see, as I drive the robot, Vicon corrects the field. Keep in mind this is running a very big program and it's remote desktoping, so it might be a little slow. But you can see here the map is not changing, which means that the pose is very, very accurate. If you see anything going wrong, the robot is not on the screen, it's not moving, chances are your Vicon connection might not be valid, or you're in a position where Vicon is not seeing the robot. The worst positions for Vicon is right underneath the center of the screen. If the robot is standing underneath the middle of the Vicon field, then it's very hard for the cameras to pick up the tags and it will not find the robot. Otherwise, you're ready to go and start using the Vicon indoors. Now we're ready to take the robot outside. Make sure you have your controller. I put on 2 battery packs, so now we have more power so we can last longer. And make sure you have a 3rd battery pack just in case something goes wrong and you want to hot swap the batteries. Okay? So as you can see, I control the robot and I'm going to drive it to another field. Let's go. So when we're outside, our best pose fighter to use Grid Slam, which simultaneously creates the map of the environment while localizing the robot. Grid Slam allows you to maintain the pose, again, for a long period of time. It is very reliable. However, Grid Slam is very computationally heavy. So as I drive the robot will correct itself and build a good map. And at the same time, Grid Slam will constantly update the robot's pose. As you can see still, the LiDAR can still pick me up, and Grid Slam can handle some interferences in creating the map. Grid Slam is also very computationally heavy.
Go.
So now we're outside. Now when we're outside, we're going to use a GPS pose provider and run the robot around. Keep in mind that there are some distractions that can occur with GPS pose provider, and read a little bit about it. When it runs, it gives you pose, and you can see yourself right here. And you notice, it's very hard to see, but you can see your pose. As you drive the robot around outdoors, and you talk about a little different things you should be aware of when you're running the robot outside. One thing is, this Segway is an outdoor platform. However, it's often, you don't want to be running into trees, you don't want to be running it in a lot of grass because it does cause a lot of vibration, it does affect the robot a little bit, but it's not a big deal. But when you drive outside, make sure you do bring an extra battery pack and you have someone with you just in case something goes wrong. If it's a beautiful day like this, the Segway is great. If it looks cloudy, be careful because you don't want it to rain on the robot. You don't want the robot to get damaged. Don't be as far away from the robot at all times just in case something goes wrong. Try to always maintain a small pace around the robot and watch. Keep the screen on just to make sure that you're still maintaining your pose and make sure that everything is running perfectly. And as you can see here, it does. Since we're out here, we can also notice that in the screen, you might notice that the LiDAR sees through glass. That's because the LiDAR uses light and it can't see through glass. So it will not be able to avoid obstacles if the obstacle is glass. So be very, very careful it doesn't run to a glass wall. When you continue walking down here, you can run the robot across the ramp down to the engineering quad and everything will maintain the pose. And it'll be great, so don't worry about it. Keep in mind that you have to load a map when you use the GPS pose provider because it needs an actual gem origin, otherwise it's going to think it's somewhere else. So there are maps created out here and you can find them in map files in Diesel, and this is where you can find the map of the engineering quad and you can use it and it becomes great. The last thing we notice is that this GPS pose finder is 6 degrees of freedom. It'll compute pitch, roll, and all the motion. So when you're driving up, it might look it's elevated, which would make sense because the robot should be elevated because it is computing the elevation too. We're going to rotate the robot around and go back into the room right now, and we'll stop.